All right, homework 23, we're going to do the ANOVA, mean squares and common population variance. Emma's on the go. A large convenience store that makes a good deal of money from magazine sales has 3 possible locations for the store for its magazine rack. In the front of the store to attract impulse buying by all customers. On the left-hand side of the store to attract teenagers who are on that side of the store looking at candy and soda. And in the back of the store to attract the adults searching through the alcohol cases. The manager at Emma's experiments over the course of several months by rotating the magazine rack among the 3 locations, choosing a sample of 44 days at each location. Each day the manager records the amount of money brought in from the sales of the magazine. Following are the sample mean daily sales in dollars for each of the locations as well as the sample variances. I'm going to move my table up a bit so that we can see what's down there. There we go. So, front of the store, sample size was 44, sample mean 218.8, sample variance 495.9, and so forth. Suppose we were to perform a one-way independent sample ANOVA test to decide if there's a significant difference in the mean daily sales among the 3 locations. Answer the following, carrying your intermediate computations to at least 3 decimal places and rounding your responses to at least 1 decimal place. So, when they ask you what is the value within the group means, what we're going to do is find the mean of the sample variance. So we want the mean of the sample variance. To find the mean of our sample variance, we're going to add all those numbers up and, in this case, divide by 3 since there's 3 numbers on our list. So we're going to take the 495.9 plus the 338.7 plus the 490.6. And then once you get that answer, if you go ahead and add all those together, 495.9 plus 338.7 plus 490.6. You should get 1,325.2. Now we're going to take that answer divided by 3 because we have 3 values on our list. When we find the mean, we add them up and divide by how many numbers are on the list. So if you take your 1,325.2 and you divide by 3, we are going to get 441.7 for our value of the within groups mean, within the group. So 441.7. For the value of the between groups mean, we have a different formula that we have to use. And what we need to do is find the standard deviation of the sample mean. Now you could use the formula for this is your sample standard deviation. That's the one where you had the way back square root and you had to do x minus this squared and that minus that squared and so forth. But we're just going to do it on our calculator. And then in order to find the variance, you are going to take that value squared, and then in order to find your answer, you're going to take the sample size times the variance. So, a couple different calculations that we have to do. First thing we're going to do is just grab our calculator, and we'll use that in order to find our sample standard deviation. So on our sample standard deviation, we're going to use the sample mean. We're going to put that in list 1. So stat, 1 for edit, and then type in your 218.8, the 212.5, and the 218.1. I scribbled over the 1 a little bit, but 218.1. Put those all in list 1. Again, if I want to find my statistics, I'm going to hit stat again, go over to calc, C-A-L-C, and we're going to calculate them on the 1 variable statistics. We want to do it for list 1. If you're using an older calculator, Shift L1 if you've got the newer calculator. List 1 should be right there. And then enter through those so that you can calculate your one variable statistics. You want the S of X number. The S of X number for the sample mean is 3.45301, so forth. It says that we have to carry at least to 3 decimal places. You could go a little bit farther than that, but at least to 3. So now what we're going to do is find the variance by squaring that number. So I'm going to take my 3.453, carrying it to 3 decimal places, and I'm going to square that. So go ahead and clear out your calculator. Do second function quit to get back to the normal screen, and do 3.453 and square that number. You should get 11.923. Again, carrying that at least to 3 decimal places. You could go farther than that, but at least 3. Now the last step, here's my first, here's my second. My last step, take my sample size times my variance. My sample size is 44. I'm just going to use that 44. So I'm going to take my 44 times my 11.923. If I take that 44 times my 11.923, I end up with 524 point, and this is going to 1 decimal place, so 6. So my between group mean is 524.6. All right. So within the group, we're just finding the mean of the sample variance by adding them up and dividing by how many numbers on my list. But when it says between the groups, we have to find the sample standard deviation. Easiest way is to use your calculator. Square that standard deviation to find your variance, and then take the sample size times your variance to get your answer for between your groups. All right. Number 2 then. Number 2 says, in an effort to counteract student cheating, the professor of a large class created 4 versions of a midterm exam, distributing the 4 versions among the 320 students in the class so that each version was given to 80 students. After the exam, the professor computed the following information about the scores. The exam was worth 200 points. So version A, sample size was 80, sample mean was 158.5, sample variance 406. Version B, sample size was 80, sample mean was 151.1, sample variance 450, and so forth. The professor is willing to assume the populations of scores from which the above samples were drawn are approximately normally distributed and that each has the same mean and the same variance. Answer the following, carrying your intermediate computations to 3 decimal places and rounding your response to at least 1. So, give the estimate of this common population variance by pooling the sample variances. When they tell you to pool the sample variance, it's asking for the same thing as when it asks for within the mean, like we did on the previous ones. So they may word that 2 different ways. Pooling the sample variance is the same thing as the within, where we found the mean of our sample variance. So we're going to start by taking our 406.0 plus our 450.0 plus our 365.3 plus our 353.9. Once we add that together, we're going to divide by 1, 2, 3, 4, since we have 4 numbers on our list. So go ahead, add those up. 406.0, 450.0, 365.3, and 353.9. You should come up with 1,575.2. You are then going to divide that by 4. And rounding that off to 1 decimal place, you should come up with 393.8. 393.8. Second part says give the estimate of this common population variance based on the variance of the sample means. When it says based on the variance of the sample means, that's like the one we did where it said between. Based on the variance of the sample means. And you can see why it's named that, because we used the sample mean and we found the variance by finding our sample standard deviation and squaring it. So, first thing we need to do is find that sample standard deviation. Use your calculator. Stats 1 to edit, and then stats, and calculate the one variable statistics. There, I'll abbreviate what we were doing there. Hopefully we've maybe done it enough that you remember how to work that on your calculator. But we're going to go ahead, hit the stat button, hit 1 for edit, clear out whatever's in there, and go ahead and type in your sample means. When we do that, we're doing the sample means in our list. So 158.5, enter, 151.1, 154.5, enter, and 154.6. So I've got my 4 numbers in list 1. I then hit stat, go over to calculate, hit number 1 for the one variable statistics. List 1 should be there unless you have the older calculator. Then just cursor through, and then you're going to look down. It's the 4th one down, the S of X, the sample standard deviation. So rounding that off to 3 decimal places, S of X is equal to 3.025. 3.025. Once we find that number there, we are then going to square it. My variance is my sample deviation squared, my sample standard deviation squared. So I'm going to take 3.025. I'm going to square that number. So again, second function quit gets you back to the normal screen where you can type stuff in. 3.025 squared gives me 9.151 if I round that off to 3 decimal places. And again, they say round it off to 3 decimal places while you're doing your intermediate computations, and then our final answer will just do 1 decimal place. And so, last thing we do, sample size times the variance. So my sample size is 80 times my variance of 9.151. Sample size times my variance. So 80 times 9.151 gives me, rounding off to 1 decimal place, 732.1. Again, you may get slightly different answers depending on how far you carry your numbers off. If you round it to 3 decimal places, or if you leave it 4 or 5 decimal places, you may get a slightly different answer. And on Alex, it knows that, so that'll be okay if you do that. All right, number 3. I have to find my number 3. There it is. Doing the same thing. This one says, at LLD Records, some of the market research of college students is done during the promotions on college campuses, while other market research of college students is done through anonymous mail, phone, internet, and record store questionnaires. In all cases, for each new CD, the company solicits an intent to purchase score from the student. 0 being the lowest, no intent to purchase, and 100 being the highest, full intent to purchase. The manager finds the following information for 100 intent to purchase scores for a soon-to-be released CD. So the sample size here, since they had 5 groups, was 20 in each group, since 100 was their total sample size. On campus, by mail, by phone, by internet, in the score, and they have all in the store, they have all of those in there. So the manager's next step is to conduct a one-way independent samples ANOVA test to decide if there is a difference in the mean to intent score for this CD, depending on the method of collecting the scores. Round the following, carrying your intermediate, or answer the following, carrying your intermediate computations to at least 3 decimal places and rounding your responses to at least 1 decimal place. Now notice they switched them around. The between groups is first this time. So that was the second one we did on the previous 2 ones. The between groups were first of all going to find our S of X using the calculator on our statistics. Since I don't have a lot of writing room, I'm just going to put that much and you guys can go from there. So we hit stat, we hit 1 for edit, clear out any data that's in there, put in your sample mean values. These ones right here. So 64.2 plus 66.0 plus 62.5 plus 72.5 plus 66.3. Or not plus, I shouldn't be putting pluses. I should hit equals. I don't want to add them, I want to put them in my list. Try that again. 64.2, enter. 66.0, enter. 62.5, enter. 72.5, enter. And 66.3, enter. Once I have my 5 values in list 1, I'm going to hit calc, or I'm going to hit stat, go over to calc, stat calc 1 for 1 variable statistics, and do them on list 1, and look for my S of X. In this case, I have 3.787, rounding that off to 3 decimal places, 3.787. My variance is then my S of X squared, so 3.787 squared. Again, second quit gets you back to the screen where you can type that in. 3.787 squared gives me 14.341, rounding that off to 3 decimal places, 14.341, and then multiplying that by the sample size. Sample size times the variance. We're using the 20 because we had 20 in each sample. So 20 times 14.341. 20 times 14.341 gives me 286.8. 286.8. Again, you may be slightly different depending on if you rounded to 3 decimal places or if you left it a little bit longer than that. On Alex, again, it's going to give you a little bit of leeway on that rounding because you might have carried your numbers out a little farther. And so if you have slightly different answer, it's probably going to count that okay. Second part of this is when we're doing the within groups. The value of the within groups, we're going to use the mean of our sample variance. So we're just going to add all those numbers together, and in this case, divide by 5. So 77.2 plus 79.7 plus 105.6 plus 149.7 plus 98.6. Divide that by 1, 2, 3, 4, 5 numbers on our list. So 77.2 plus 79.7 plus 105.6 plus 149.7 plus 98.6 should give you 510.8. We're going to divide that by 5. If you take your 510.8 and divide it by 5, we should get 102.2 when we round that off to the nearest tenth. All right.